Okay, so today we're starting area between functions. Okay, these are our two equations that we use. Okay, this one is if we're using the vertical strips, and this one if we're using horizontal strips. So notice if I'm talking about the area between two curves and I'm doing vertical strips, it's the top function minus the bottom function, and the functions themselves have to be in terms of x because my width is dx. If we're doing horizontal strips, which look like this, these are vertical strips. Horizontal strips look like this, which means they're perpendicular to the y-axis. Then our function is right minus left, but they have to be in terms of y because my integral is going to be in terms of y. Okay? So, I've given you two functions. So find the area enclosed by these two functions. Well, I don't know if I'm going to be doing vertical strips or horizontal strips yet. Okay? So the best idea is to sketch it. Okay, so I give you this graph here so you could sketch it. Now, a linear function, you should know how to graph that. Okay? It's got a y-intercept of 3, 1, 2, 3, and a slope of 1. So this right here, this is my line. Okay? And then my quadratic right here, okay, it's in its vertex form, so I know the vertex is at 2, 1. I also know that it's been vertically compressed by 1/2. So it'll go over 1 up 1/2. Yep. And should end up right here. It'll be over 2 up 2. It's been cut in half. Same thing here. Over 2 up 2. 1, 2, 3, 4. And then here. So, and then of course on the side. Yep. So this is my function. Okay. Now, at this point, you got to decide, are you going to do vertical strips or horizontal strips? Okay. Now, really easily you can see if you end up doing horizontal strips, here you're going to hit the same function twice, and then here you're going to hit two different functions. So you'd have to split that one up into two separate functions, or two integrals. So we don't want to do that. So most likely we're going to be doing vertical strips. So I'm going to show just one vertical strip like this. Okay? So that vertical strip is going to tell me which one my top function is and which one my bottom function is. So this function right here, that is my top function. And this one right here, that is the bottom function. So when I go to set up my integral, I know that this is from a to b, my function top minus function on the bottom, dx. Okay? Now, to make things easier, you should probably FOIL out this function, f of x. And when you do that, you get 1/2 x squared minus 2x plus 3. Okay? So when I plug in my function, I'm going to get the top function, which is x plus 3, minus the bottom function, which is 1/2 x squared minus 2x plus 3 dx. Okay? Now notice I put both of them in parentheses, and this is for two reasons. One, it shows you which function is the top one, which function is the bottom one, but also since I have subtraction going in here, I have to remember to distribute all the way through. Now the only other thing that I'm missing here are my limits, my a and my b. So we got to figure out where my area starts and where my area finishes. Okay, and since we're doing it in terms of x, it's the x values where it starts and finishes. So this right here, that's where my area starts, and this point of intersection here, this is where my area ends. So my limits are from 0 to 6. Now, we didn't have to graph this. We really didn't have to. It helps to graph it to see what you're doing vertical or horizontal. Okay? But we could have done the same thing by plugging in, we could have found the points of intersection by setting these two equal to each other. So if you wanted to, remember to find where two functions intersect, you set them equal to each other. So you set g of x equal to f of x, and you plug x plus 3 equals 1/2 x squared minus 2x plus 3. And you find the solutions. And when you do that, you get 0 equals 1/2 x squared minus 3x. And then you get, factor out 1/2 x, and you get x minus 6. So your zeros are at 0 and 6, which means those are my 2 points of intersection. And then all you have to do is pick a point anywhere between there and plug it in and figure out which one's a bigger value. So say I plugged in 2. When I plug in 2 into my top function, I get 5. When I plug 2 into my bottom function, I get 1. So which one's on top? That would be that one. So that's another way of doing it. Okay, so if you don't want to sit there and graph it, you don't have to. Now, time for the easy part. We evaluate our integral. So we distribute the negative through, so we get from 0 to 6, and we get x plus 3 minus 1/2 x squared plus 2x minus 3 dx. So we get from 0 to 6, negative 1/2 x, and you get plus 3x dx. And now take the antiderivative. Sorry, this is supposed to be squared. Take the antiderivative, so add 1 to the power. So we get x cubed over 3, this is 1/2, plus 3x squared over 2 from 0 to 6. We don't have to plug in the 0, so we just plug in 6. And then we're going to get, this would be 6 cubed, or negative 6 cubed over 6, plus 3/2 times 6 squared, like that. And 6 cubed divided by 6 is 6 squared, so this is negative 64, plus 6 squared, what am I, 64, 36. Negative 36, and 36 squared divided by 2, that would be times 3, 54. So 54 minus 36 would be, just make sure, 18. And that's our area. So the only thing that we're doing different from definite integrals that we've been doing is setting up our equation. It's a little bit more difficult because we're going to have to find the points of intersection. So we need to find the points of intersection to set up my limit, and then we got to figure out which one is the top function and which one's the bottom function if we're doing vertical, or right minus left if we're doing horizontal.